Today's a big day. You're about to build your very first working circuit. This is the circuit we have been seeing in all our examples. A battery, a light, and one small addition, a resistor. Before getting started, let me tell you a quick story. When I first got into robotics, this is the exact circuit that almost made me give up. I was randomly connecting wires, hoping and praying something would light up. But I had no idea what voltage, current, or resistance were, which made it really frustrating. But once I figured it out, everything clicked and the light appeared. Literally. So let's make sure you don't face the same struggle. Let's get started. Let's take a look at our circuit diagram for today. Here's everything you need. You'll want to grab your kit and pull out the following components. A breadboard, which is our testing ground for circuits. It lets us connect components without any permanent connections. 4 male-to-male jumper wires. It's the ones with the 2 pointy ends. These act like pipes, carrying electricity between parts. Then you'll want a 1 kilo ohm resistor. Like our sand filter from the water analogy, it slows the flow of electricity so components don't burn up. Yours should be brown, black, black, brown, brown, okay? And LED, or light emitting diode, so this is the component that we're gonna light up. You can choose any color you'd like. I'm gonna use yellow. Then you'll want a 6-volt battery pack, and this will act as our power source. And in that battery pack, you'll need 4 AA batteries. If you still need AA batteries, I personally use these ones from Amazon. They've worked great for me. Below is an affiliate link. I may earn a small commission at no extra cost to you. So what is a breadboard? A breadboard is a tool that makes building circuits quick and easy. No soldering required. The name breadboard originates from early electronic enthusiasts using literal breadboards, which were wooden cutting boards to build circuits. The name kind of just stuck, and now these guys are known as breadboards. Under the hood, it's just rows and columns of metal strips that connect specific holes together. Let's break it down a bit more. These vertical columns on the side are known as the power rails. They are marked with a plus for the positive side of our power source and a negative for the negative side of our power source. We use these to distribute power or voltage in our circuit. Voltage is the difference in energy from 2 points. So we say that the negative side is 0 volts and the plus side is 6 volts. So the difference between these 2 rails is just 6 volts. It makes the math really easy. So every hole on the plus side has 6 volts and every hole on the minus side has 0 volts. These horizontal rows in the middle are known as the terminal rows. Each set of 5 holes in a row is connected. This means that each set of 5 holes has the same voltage, but the left and right sides are separated by a center gap. This gap separates both sides of the breadboard. It's perfect for placing components like resistors or LEDs across, which we'll do in just a second. If you're wondering how these connections are made in a breadboard, if you open it up, you'd see metal strips forming these hidden connections. That's what makes it modular and super easy to use. So the key idea here is you're not plugging wires in randomly. These rows and rails are designed to create organized, testable circuits. All right. Enough talking, let's start building. Alright, let's begin connecting things to the breadboard. Let's start with the battery. Connect the red wire from the battery pack to the plus symbol on the power rail. Nice. Now connect the black wire to the minus symbol on the power rail. This distributes the 6 volts across the board. Okay, now we're gonna place the resistor. Insert one leg of the 1 kilo ohm resistor on one side and then across to the center gap. Okay, now we're gonna place the LED. Pay attention to the legs. This determines polarity. The long leg is known as the anode and must have a higher voltage than the cathode. The short leg is known as the cathode. So the long leg of the LED goes into the same row as the resistor, and the short leg goes into a new row. Cool. Let's complete the circuit with jumper wires. Connect the resistor side to the plus side of the rail with a jumper wire, and then connect the LED's short leg to the minus side of the rail. And let there be light. When everything is connected correctly, the LED lights up. You have officially built your first working circuit. Congratulations. If you ever get stuck, just read the circuit out loud to make more sense of it. We go from the positive terminal of the battery to one side of the resistor to the other, to the long leg of the LED, to the short leg of the LED, to the negative terminal of the battery. And this completes our loop. Now, what happens if you run into problems and need to diagnose it in your circuit? That's when we use a multimeter. A multimeter is a tool that measures voltage, current, and resistance. Let's see how to measure voltage. First, you want to plug in your cables into the multimeter. And don't make the same mistake I did. You want to take off the covers from the head of the cable. There you go. Great. That plugs in very nicely. You want to plug your cables into the first two holes to the right-hand side. Now that we've got that done, let's turn the dial to DC voltage. Look for the V with a straight line and a dashed line right under it. There we go. Let's choose a range. These numbers here tell you the maximum amount of voltage you can measure. So if you set the dial to the 2-volt range, you get a weird reading from the multimeter. So if I connect it, it kind of just shows you 1. And that's telling you, hey buddy, you're kind of exceeding your limit right now. So that means you have to go to a higher setting. So if we choose the 20-volt maximum range, since we're using 6 volts, it'll be within its maximum range, so you won't get a weird reading. Let's check it out. So you'll want to touch the red probe to the plus rail, or the red wire. That's how I usually like to remember. And you touch the black probe to the minus rail. You should see a voltage close to 6 volts. I'm getting 5.46 volts. And for our applications, we'll say that's close enough. Cool. Now, let's measure voltage drop across components. Let's measure how much voltage each component eats up. So if I put the multimeter probes to the resistor, so if I say from this guy to this guy, so you get 3.44 volts. That's how much voltage the resistor is eating up. All right, now what happens if we put them across our LED? So that tells us that our LED is eating up approximately 2 of those volts. And that makes sense, because we know from physics that energy can't be created or destroyed. The total voltage coming into the circuit should sum up to the total voltage exiting the circuit. And we got around 5.46. This eats around 3.4 something, so that math adds up. So we start with 6 volts, then the resistor eats up 3.4 something, and the LED eats around 2 volts. Since ground is 0, by the time we travel through the entire circuit, the energy levels go back down to 0 and recharged when they go through the battery. There's a special formula we can use to know how much voltage certain components use up, but that's for later. Now let's measure current. To measure current, we need to place the multimeter in series with the circuit. First, let's turn the dial. Set it to DC current and choose 20 milliamps range. So the maximum current we can measure is 20 milliamps. Now, we need to break the circuit and rebuild it a bit to include the multimeter directly in the path. Remove the jumper wire from the LED's short leg to the negative rail. Insert the multimeter's probes in place. The red probe goes to the cathode or the short leg of the LED, and the black probe goes to the ground rail. You'll likely see a small value, a few milliamps coming from the multimeter. Mine is currently reading approximately 2.3 milliamps. And this tells us exactly how much current is flowing through our circuit. Now, let's measure resistance. Let's check the resistance of the resistor directly. Again, we want to turn the dial. Turn it to the ohm symbol, which is a little squiggly looking symbol, and choose 2 kiloohms. This means that the maximum resistance we can measure is 2,000 ohms. Now, with the power off, we're going to touch the probes to both legs of the resistor. You should see around 1,000 ohms. Beautiful. Right now, it's reading around 997 ohms, which is really close to 1,000, so we'll call that good enough. If you're ever feeling lazy and don't want to use the colored code table, you can just grab your multimeter and measure the resistance of the resistors. Let's wrap things up. You did it! You built your first working circuit. Congratulations. You used the multimeter to measure voltage, current, and resistance, and you're officially working with real electronics. If anything still feels a little bit confusing, don't worry. This stuff takes practice. The more we cover the fundamentals and build these circuits, the more natural it'll be. If you're feeling proud of your circuit, take a picture of your working circuit and tag us. Our Twitter, Instagram, and TikTok is at Horizon Robotics Lab. Up next, we're going to dive deeper into current and resistance so you can design even more exciting circuits on your own. See you in the next one. If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description and happy learning.